students, welcome to the next video of application of derivative. In previous video we had seen the what is the application of derivative, then how to find the second order derivative. In today's video we are going to use second order derivative, or I can say we are going to use derivative to find tangent and normal. Not tangent and normal, basically we are going to find equation of tangent and normal. So first let us see what is this tangent and normal means. So tangent is the line that touches the curve at a point and doesn't cross it, whereas normal is the perpendicular to that tangent. For example, this is the curve, then line just touch this curve and passes through this curve is known as a tangent. Okay, and normal is a perpendicular on this line. Okay, this line is known as a normal and this line is a tangent. Okay, so let the tangent meet the curve at point P x1 y1. That means this is the curve and this is the tangent. Now this point where it meet the curve, this point is suppose P with coordinate x1 y1. Okay, so now the straight line equation which passes through the point having slope m could be written as y minus y1 equal to mx minus x1, because we know the slope and we know the one point on a straight line. Okay, so by slope point form we get equation of a line as y minus y1 equal to m into x minus x1. We can see from the above equation the slope of the tangent to the curve y is equal to f of x, and at the point P x1 y1. Okay, it is given by dy upon dx. Okay, so slope of a tangent means m, and that is equal to dy upon dx. Okay, where y is a function of x, y is equal to f of x, then slope is given as a slope of a tangent is given as a dy upon dx. Okay, so we get equation of a tangent will be y minus y1 is equal to f dash means derivative of x, right, which is also denoted by dy upon dx. Okay, into x minus x1. So first formula is slope of a tangent, right? First we have to find slope of a tangent, which we are going to denote by m1, and m1 is equal to simply dy upon dx. Okay, then we have to find equation of a tangent, okay, at point x1 y1. Okay, so equation will be y minus y1 is equal to m1 into x minus x1. Okay, so to find the equation of a tangent, first we have to differentiate y with respect to x, that will be a slope. After finding slope we will apply the formula for equation of a tangent, which is y minus y1 equal to m into x minus x1. Now similarly we can find equation for normal. So for normal, first we have to find the slope for normal. So as we know that tangent and normal both are perpendicular, right? Hence slope of a normal that is equal to, denoted by m2, that is equal to minus 1 upon dy upon dx, right? Normal and tangent are perpendicular lines, hence their slope, their slope will be m1 into m2 is equal to minus 1, because tangent and normal are perpendicular to each other, and hence we get slope of a normal as minus 1 upon dy upon dx. Then equation of normal will be y minus y1 equal to m2 into x minus x1. Okay, so that is the equation of a normal. Okay, now let's see example. So first example is find the gradient. Gradient means slope. So find the slope of the curve y is equal to root of x cube at x equal to 4. So what is given? Y is equal to root of x cube is given. Now this root of x cube, can we write this as x cube raised to 1 upon 2, and that is equal to x raised to 3 upon 2. Okay, so y is equal to x raised to 3 upon 2. Now we have to differentiate this with respect to x. So dy upon dx, that is equal to, we have to apply x raised to n formula. So that is equal to 3 upon 2 x raised to 3 upon 2 minus 1, right? So that will be 3 upon 2 x raised to 1 upon 2, right? 1 upon 2 means root. Okay, so 1 upon 2 means root. So we are getting 3 upon 2 into root x. Okay, 3 upon 2 into root x. Now they have done by using, they have find this dy upon dx by using composite rule. Okay, so derivative of root x cube, that is equal to 1 upon 2 root x cube into derivative of x cube, right? Composite rule. So that will be 1 upon 2 root x cube into derivative of x cube, x raised to n formula, so 3x square. Okay, so we'll get 3x square upon 2 root x cube. Okay, which is very complicated, so better you can simplify and then find the derivative. So what I am going to do, I am going to write this root of x cube as x cube raised to 1 upon 2. So that is equal to x raised to 3 upon 2. Now I will find the derivative. So derivative will be 3 upon 2 into x raised to 3 upon 2 minus 1. That means I am getting 3 x raised to half upon 2. Okay, so that is the derivative. Now raised to 1 upon 2 means root x. So finally what I am getting? I am getting 3 root x upon 2. This is my dy upon dx. Okay, now what I have to do? Now in next step I have to substitute x value. Now see here, x is given as 4. Let me clear the screen, then I will show you. See, x is given as 4. So I have to find dy upon dx when x is equal to 4. So that is equal to 3 root 4 upon 2. So that is equal to 3 into 2 upon 2. So 2 cancel. So I am getting 3. Okay. So dy upon dx when x equal to 4 is 3. This term. Okay. So gradient means slope. So slope of the curve is nothing but dy upon dx. Okay, and dy upon dx is 3. So slope is 3. Now see the next sum. At what point on the curve y is equal to e raised to x, the slope is 1. So y is equal to e raised to x is given. What we are going to do? We are just differentiating with respect to x. So derivative of y will be dy upon dx. Derivative of e raised to x is e raised to x. Okay. Now slope is given as 1. Right? Since m means dy upon dx is equal to 1. So e raised to x is equal to 1. And we know that any number raised to 0 is 1. So I can write this one as e raised to 0. Okay. So e raised to x is equal to e raised to 0. Therefore x is equal to 0. Okay. By comparing we get x as 0. Now after getting x value, what we are going to do? We are going to substitute this x in this equation. So we will get y value. So y is equal to e raised to 0. E raised to 0 is 1. So I have to find point now. So point is what? Point is x value, which is 0. Then y value, which is 1. Clear? First we have to differentiate with respect to x. Then we have to put slope as 1, means dy upon dx as 1. And by comparing we get x equal to 0. Then we will substitute this x value in y and we get y as 1. So point is 0 and 1. Okay. See, next example is find the point on the curve y is equal to 3x minus x square at which slope is minus 5. So y is given as 3x minus x square. Now we are going to differentiate with respect to x. So dy upon dx is derivative of 3x 3. Derivative of x square 2x. Okay. So 3 minus 2x. Now slope is given as minus 5. So we have to equate this as minus 5, right? Dy upon dx value is given as minus 5. So that means 3 minus 2x equal to minus 5. So 3 plus 5 is equal to 2x. 2x equal to 8. X equal to 4. Okay. Now I got the x value. So I am going to put this x in y equation. So y is what? See here. Y is 3x minus x square. So 3 into 4 minus 4 square. So 12 minus 16 minus 4. Okay. So x is 4, y is minus 4. So point is 4 minus 4. Okay. See next example. Next example is at what point does the curve y is equal to x square minus 24x plus 2 have slope equal to 3. Okay. So what we are going to do first, we are going to differentiate this with respect to x. So dy upon dx is 3x square minus 24. Right. Derivative of x cube. Derivative of x cube is 3x square. Then minus derivative of 24x is 24. Then derivative of 2, 0. Okay. Then slope is given as 3. Means dy upon dx is 3. So what we are getting? We are getting 3x square minus 24 is equal to 3. So that means 3x square is equal to 24 plus 3. 3x square is equal to 27. So x square is equal to 9. So x is equal to plus minus 3. Okay. Now after getting this x value, x is plus minus 3. Now when x equal to minus 3, okay, then we substitute x as minus 3 in this equation and we will get the y value as 47. So when x equal to minus 3, then y equal to 47. Then when x equal to 3, then substituting 3 in this equation, we get y as minus 43. So when x is 3, y will be minus 43. So points are minus 347 or 3 minus 43. See next example. Find the equation of tangent to the curve y is equal to x square minus 2x minus 3 where it meets the x-axis. Okay, here point is not given, so it's okay. First we have to differentiate. So equation is y is equal to x square minus 2x minus 3. So first we are going to differentiate this equation. So derivative of x square, derivative of, okay, before that let's find the point. Okay, so to find the point, what we are going to do, since the equation of tangent meets the x-axis, right? So when it meets the x-axis, then y coordinate will be 0. So we'll put y as 0 in this equation. So we get x square minus 2x minus 3 equal to 0. Then we will factorize this equation. So factors will be minus 3 plus 1. So x minus 3, x plus 1 equal to 0. That means either x equal to 3 or x equal to minus 1. Okay. So points are, these are the x value. So when we substitute this x, when we substitute x as 3 in this equation, then we get y is 0, right? It meets the x-axis now. So at x-axis y coordinate is 0. So point is minus 1 0 or 3 0. Okay. Now next is we find dy upon dx. So dy upon dx will be derivative of x square is 2x minus derivative of 2x is 2. So 2x minus 2. Okay. So slope of tangent dy upon dx is 2x minus 2. Now at point minus 1 0, at point minus 1 0, we put x as minus 1 in this equation. Then we get dy upon dx means m as minus 4. Slope is minus 4. Okay. Now after getting this slope, we will find the equation. Equation of tangent passing through the point minus 1 0 and having slope minus 4. Okay. So formula is y minus y1 equal to m into x minus x1. So y minus y1 is 0. Then equal to m is minus 4 into x, then minus 1. So x plus 1. So y is equal to minus 4x minus 4. So 4x plus y plus 4 equal to 0. Now at 3, 0, okay, slope is, put x as 3. So we get slope dy upon dx as 4. Again to find the equation of tangent, we have to apply this formula y minus y1 equal to m into x minus x1. So y minus 0 is equal to 4 into x minus 3. So y is equal to 4x minus 12 means 4x minus y minus 12 equal to 0. Okay. So there are two equations at 1, 0 at the point minus 1, 0. Slope is minus 4 and equation is 4x plus y plus 4 equal to 0. And at 3, 0 slope is 4 and equation is 4x minus y minus 12 equal to 0. Okay. Then see one more example. Here question is find the equation of tangent to the curve x is equal to 1 upon x and y is equal to x minus 1 upon x. Okay, where x equal to 2. It is 1 upon t. X is 1 upon t and y is t minus 1 upon t, and t is given as 2. Okay. Now this is parametric function, right? So first let us find the point. So when t is equal to 2, then x will be 1 upon 2, right? So when t is 2, then x will be 1 upon 2 and y will be 2 minus 1 upon 2, means 4 minus 1 upon 2, that means 3 upon 2. So point is 1 upon 2 comma 3 upon 2. Now x is equal to 1 upon t is given, right? So we will differentiate x with respect to t. So derivative of 1 upon x is minus 1 upon x square. Then y is t minus 1 upon t. So derivative of t is 1. Then minus derivative of 1 upon t is minus 1 upon t square. So that is equal to 1 plus 1 upon t square. So t square minus 1 upon t square. Okay. So finally what we will get? We will get dy upon dx as dy upon dt upon dx upon dt. Okay. Then we substitute this value, t square plus 1 upon t square into minus t square upon 1. So finally we will get minus t square plus 1. Okay. So slope of tangent at t equal to 2. So we'll put t as 2. So we get minus 2 square plus 1 means minus 5. So slope is minus 5. Okay. Then after getting this minus 5, next we have to find the equation when this tangent is passes through the point 1 upon 2 and 3 upon 2 with slope minus 5. Then formula is y minus y1 equal to m into x minus x1. So y minus 3 upon 2 is equal to minus 5 into x minus 1 upon 2. So after cross multiplying we get this. Okay. Then multiplying both the side by 2 and then simplifying we get equation as 5x plus y equal to 4. That is the equation of a tangent. Okay. So with this I am concluding my second video. In second video we had seen what is the formula for finding equation of tangent and equation of normal, and how to find equation of tangent and equation of normal. So thank you students.